Hi everyone, in this video, let's explore why the current remains the same throughout a series circuit. To understand this, we'll start with the simplest possible example, a basic series circuit. Here, I have a battery and connected to it is a resistor. Before diving in, let's go over some fundamental ideas about circuits. I'll be using a highly simplified approach to help you visualize how electrical circuits work, making them easier to understand. Let's start by imagining these connecting wires as highways or paths through which the current flows. But what do we mean by flowing current? To keep things simple, let's picture it as a stream of electrons moving through the wire, similar to traffic on a highway or water flowing through a pipe. A quick side note here is that this isn't exactly how it works, but for now, this simplified view will help us understand the concept. Now let's zoom into these wires and visualize the electrons flowing through them. What does the battery do? Well, we know it drives the current in the circuit. But how? For now, let's imagine the battery as a source that gives energy to the electrons. At the negative terminal, it provides electrons with potential energy and repels them, setting them in a motion through the circuit. As these electrons move, they pass through the resistor, which obstructs their flow. This resistance slows them down, but they continue moving forward. Eventually, they reach the positive terminal, having lost all the energy they initially gained. Through a chemical reaction, the battery then transfers these electrons back to the negative terminal, where they regain their potential energy, allowing the cycle to continue. So far, we focused on just a small batch of electrons. But in reality, electricity does not flow in small batches. It flows continuously. Now, let's look at the bigger picture where all the electrons are moving together in a steady flow. The key thing to notice here is that because the electrons are traveling in a closed loop, they must all move at the same speed. When electrons pass through the resistor, they slow down due to the resistance. This in turn slows down the electrons behind them, causing the entire flow in the whole circuit to be affected. This is similar to a traffic jam. Imagine a rough patch on a highway that forces cars to slow down. As a result, all the cars behind it are also slowed down, creating a traffic jam. Now, if this highway were circular, like a closed circuit, this slowing effect would spread across the entire loop. The speed of the entire traffic flow would depend on that one slow patch. Similarly, the flow of electrons in the entire circuit depends on the resistance of the resistor. To make this idea even clearer, let's consider a case where the current is not the same throughout the circuit and see what happens. Suppose the current at point A is higher than at point B. This would mean that every second, a higher number of electrons are entering the resistor, but a smaller number of electrons are exiting it. But how is that possible? Where would the extra electrons go? Are they accumulating inside the resistor or simply disappearing? Clearly, this cannot happen. Since charge cannot just vanish or build up indefinitely in a resistor, the current must be the same at all points in a series circuit. Thus, the current in a series circuit remains constant throughout. One last thing to note is that I have considered the actual flow of electrons as the direction of current here. Historically, people believed that current was carried by positively charged particles, so they assumed it flowed from positive terminal to the negative terminal. This convention persisted and is now known as the direction of conventional current. To stay consistent with standard notation, we will have to use this conventional current direction in all further discussions. That's it. Thank you.